There is, of course, the biomass, which is here argued to be a bridge going to full renewable and not really a solution in the end, because there are many issues associated with that. Nonetheless, ranking and results by 2050 is at 34, with a saving of expected saving of 7.5 gigatons in terms of CO2 reduced. The net cost over 30 years of operation is 402.3 billion US dollars, with net savings of 519.4 US dollars. 19.4 billion US dollars. There are lots of issues. What is fed to these energy production systems? Here is an example. This is a single pass cut and chip harvester reaping fast-growing willow for a carbon-neutral biomass plant, part of Germany's Energiewende. I don't know how to say it. Maybe it's Energiewende. Or energy turnaround. Germany currently produces over 30% of its energy from wood. But when the total cost of harvesting and processing wood is calculated, it is not carbon neutral. Okay, so it has a net emission. The industry exists because of a significant government subsidies. That's something to remember. So there are fast-growing trees. Willow is one of them. For a country like India, for example, eucalyptus, which when cut close to the ground can regrow, so that can be fed to these biomass energy systems. But eucalyptus is also an invasive species. It's a water guzzler, and there are all sorts of other issues. There are ideas of feeding it these systems agricultural waste without harming the biomass that has beneficial effects when left in the field. Other waste that is produced by residents, humans, and so on. So it's not completely a clear solution. So here, biomass is argued to be a bridge solution phased out over time in favor of cleaner energy sources. So it cannot even be argued to be completely clean off the bat unless all the issues are taken care of. For example, there is arguments that the conversion of biomass to energy takes a very short time, but the growth of that biomass takes much longer. So the carbon cycle aspect of how long it takes for carbon to be sequestered and then released back into energy and the emission to be created, and whether that can be really made carbon neutral are issues. Plus, there is also the concern about whether biomass can begin to compete with land and resources or prices, grains, etc., for food. So there's a potential competition with food. The advocates would argue that many of the biomass that can be fed to these systems, like switchgrass and various other things, can be grown on abandoned land or land that is not used, but there is always the concern of indirect impact on deforestation, because the argument also is that when logging is done at industrial scale, the material that's not used can be also used for biomass energy production and so on. So this is a debate that goes on. Nonetheless, if you think of it as a bridge solution, the analysis here assumes all biomass is derived from perennial bioenergy feedstock, not forests, annuals, or waste. Okay, so it is perennial bioenergy feedstocks, the material that's fed to the bioenergy production systems, and they replace coal and natural gas in electricity production. So you have to replace something that's more carbon intensive also. By 2050, biomass energy could reduce 7.5 gigatons of carbon dioxide emissions. As clean wind and solar power become more available in a flexible grid, the need for biomass energy will decline. So all the concerns and so on. For example, India is trying to remove some invasive species in specific forests in the northeast, like the state of Sikkim, and convert them to pellets and other forms of clean biomass for cooking and so on, which actually reduces the emissions by a lot and indoor pollution by a lot. So that is a helpful thing, but doing it carefully, and the net investments versus net benefits, carbon CO2 emissions reduced and so on, have to be closely tracked as well. Okay.